Hello, my name is Matthew Ringel. I'm from Tufts University. I'm here to talk about, according to the title, Coherent Naming Schemes, a Case Study, or what to do when you get fed up and decide to rename every one of your network devices. So, here's pretty much how it worked. Somewhere around February to March of this year, we realized that we needed a standard naming convention for everything, including routers, switches, wireless APs, of which we're getting large amounts of very, very quickly, security devices, and of course whatever comes up next. Now, this kind of need doesn't come from out of the blue, so what drove it? It was horrible. 3 campuses, all in eastern Massachusetts, varying widths apart, 15 routers, 400 switches, and many, many ways of naming things. There was no standard. It was very, very much ad hoc. It was whoever deployed it said, well, okay, it's on the second floor of the psychology building, so I'll name it Psychology 2, or Psychology 2 Unit 0 if they were being really, really technical. Alternately, get people naming things by the name of by what the equipment was. So there's the 7507 in Miller Hall, so we'll name it Miller 7507, or stuff along those lines. It really took hits on productivity. I mean, you don't think about it all that much, but I mean, in terms of troubleshooting, okay, fine. Well, we know that, a data tech call said, well, it's the switch in room 215. Well, we don't have any switches that are named something 215. Okay, well, that's on the second floor. Okay, it's in that building. Maybe that's the switch we meant. And then, okay, well, is that the one? Well, maybe. Is that the one? Well, maybe. And you end up going through and it takes 10 minutes and it sucks. So, then you have stuff like equipment deployment. Even saying, oh, I got to name this device, so what in the world do I name it? I have no idea. Well, it goes here. I'll deal with it later. And if deal with it later means one day here and one day there for another device, you put enough devices out in the field, you're talking about large amounts of delays in deployment, just because it's a little bit harder for someone to do their job. And not all that much harder either. Documentation, I think it can pretty much go without saying, and automation efforts as well. If you don't have a standard naming scheme, there's no real way to say, well, okay, that's what the switch is named, that's how we'll monitor it. So here's what we had. When we had a building, well, what was it? Well, it's the psychology building. Well, it's 8 Winthrop Street. Well, it's Carpenter House. Well, it's building M52, according to Buildings and Grounds. And each of these got used in turn at various points whenever somebody named them. Just to call it organic growth, I guess would be the nice way to put it. Location information, well, okay, fine, there's no number on this room, but that's where the switch closet is, so we'll call it by the room next to it and we'll just figure it out when the time comes. Inconsistent data in the name. So, okay, so TAB is the name of a building, a Tufts Administration building. So, okay, it's TAB and it's in the data center and it's a big iron or fast iron 15K and it's in quad A and it's unit 1. Or you've got the TAB big iron, wherever that may be. Or the research in 2 probably means something, and the FI8K, well, whatever. And then you have arbitrary interface names, Tufts PRI border, which looks really cool on a trace route, but that doesn't actually mean anything. Or SAC router 5, which means something to people once they get enough institutional memory, but not until then. Now this top one, this actually happened. I had someone tell me, everyone knows that the switch for Cousins Gym is actually in Halligan Hall in that room that doesn't have a number on the door. In fact, I have also had somebody tell me, that switch is in the room where that switch they uninstalled 2 years ago used to be. Yes, this is New England. Those kind of directions, while cute, aren't really useful. So even though you hear them all the time. So, also names based on device hardware. Sackler 7507. Okay, well, it's in the Sackler building and it's a 7507. Okay. That could be useful to somebody right up until the point where you fumble through and you figure out what people talking about and you talk to the data techs and you figure out what they meant and you realize that, oh yeah, we changed that into a big iron, sorry. Myth of naming security. I've heard people say, well, do you want your names to be totally scrutable by someone doing a trace route from the outside? And besides saying, okay, a sufficiently dedicated attacker is going to be able to map your network no matter what you do. And why make it harder for you if you're not making it any harder for them? I mean, sure, you could run split-brain DNS, and anybody outside would have anything in the net Tufts edu domain resolved to chicken. I don't particularly care, but you know, all the chicken in the world is not going to stop a sufficiently dedicated attacker from figuring out exactly what's going on. And someday you will be outside your own network and you're going to want to traceroute in. And chicken will not help you either. So what we needed, we decided, okay, what does a naming scheme have to have? Well, comprehensible. You have to be able to read it and know exactly what it means. I mean, that pretty much goes without saying, with the exception that I said it. Extensible, well, whatever the future needs are. You have to do a little bit of planning out and figure out what's going on and understand, okay, what kind of devices are you going to have next? Can they adhere to whatever naming scheme you craft up? I'll skip derivable for a second and come back to it. Self-documenting, you've got to be able to, it sounds odd to say, but you've got to be able to do a traceroute and have it tell a story. You've got to be able to look through as soon as it hits your DMARC and know exactly what interface that packet hit and how it made its journey through your network until you get to the end, because that's when debugging via traceroute is worthwhile. Unique, one name to one device. You have to come up with a minimal set of data that will create a name that is unique. You can go through a whole naming scheme and realize, well, wait, by that token, these two devices would have the same name, and you have to start over again. As for derivable, this was my big one. It has to be formulaic. You have to say, given a set of parameters, let's say for a switch, if I give you the building name and the room number, you should be able to synthesize in your head what the name of that switch would be, even if you're not actually looking at maybe your DNS allocation database or the piece of paper you scribbled on or the post-it note on your monitor, wherever. You've got to be able to create it in your head. What this does is it changes the name from being just this magical incantation that's a series of 20 characters that you're typing in to get to this device to a concept in your head. And you're much more likely to get it right on the first time. And you're actually going to say, okay, it's this switch in this, it's this switch in this place, and so I type it out like this, and it all will be there. And if you get it right on the first try, you get large amounts of productivity gains instead of having to look aside to somewhere else to understand what's going on. So, some things we looked at and then threw away or decided were bad, using telco codes. So let's take CMBR-MAKS, Cambridge, Mass, Kendall Square, that would be East Cambridge, which I guess means something to the telco. And I've seen various corporations use this kind of naming scheme, or SOMRMATS for Teal Square in Somerville, Mass. And that's cool and everything, but we realize that we're not a telco. Why would we use telco names if we're not a telco? These names do not give us the resolution or the information we need. There is no particular reason we have to limit ourselves to 8 characters or must fill in 8 characters. There's, we've got 3 campuses. We know what their names are. We don't have hundreds of points of presence everywhere. There's no reason to go with this very, very compressed code for a resolution that gets us down to 1/3 of a city, which we really don't need. And eventually, the telcode will change its standards. And then now you will have your own special telco-derived standard for naming things that has very little to do with anybody. Compression artifacts. Everyone abbreviates differently. That's just the nature. What's easy to remember for somebody is harder to remember for somebody else. As you put stuff in and everybody has their own opinions on abbreviation. For example, if we take the name of the medical school building, Sackler, S-A-C-K-L-E-R. Well, you could either spell it out, and that's 7 letters. You could abbreviate it to the first syllable, S-A-C-K, 4 letters. You could abbreviate it to a TLA, S-A-C. And that's all fine, but everybody's going to have a different opinion on what is useful to them. And so, lacking a standard, you will see it abbreviated, and we did see it abbreviated any number of ways. Avoid using equipment types. Equipment's replaced or upgraded. This has happened any number of times. If DNS is, there's any number of ways to abuse DNS. In my opinion, one of the ways not to abuse it is asset management. That's not where it belongs. It doesn't matter when you're trace routing that something is a 7507 or a big iron or whatever, as long as it's routing packets. So why bother putting in the name? Because and much like comments in a program where you're modifying the code and not the comments lie. So why put the irrelevant information in? Make sure that restrict the name to a location and a role. This way, the name's going to stay the same regardless of what hardware is actually filling those shoes. So, if the telco is an authoritative naming source and our own wild imaginations aren't an authoritative naming source, find an authoritative naming source. In this case, this would be the Space Planning Department of Tufts University for building names, and they gave us a very, very nice spreadsheet that had everything on it and the official names for buildings. And that's what we use. You have an authoritative source, you can continually go to it, they update it, not us, and it's within the university. The Buildings and Grounds Department for actual room numbers. As it turns out, this was a service for everybody involved because they actually put room numbers on a lot of the rooms after we were done with it. So a formal grammar. I actually wrote up a formal BNF LALR1 grammar for the naming scheme and turned the crank and put every single device we had through that naming scheme just to make sure it would fit. And this failed a couple of times, and that was good. But the idea being that not only does it have to be human readable, but eventually it is going to have to be computer parsable too for any sort of information to take, any sort of automation to take hold. And so starting out with that idea from the beginning was really, really important. List the assumptions about your network. If you try for the overall, be-all, end-all naming scheme of some platonic ideal of a network, you're going to end up with the naming scheme for some platonic ideal of a network, which probably has very little to do with yours. So list what your assumptions are. List what your basic topology is, maybe where your topology may be going, to understand what is important in your naming scheme. In our case, it's combined layer 2 and layer 3 core with a dark fiber man link to our Boston campus from Medford, approximately 10 clicks away, and a managed WAN link to our Grafton campus, which is 40 clicks away in the other direction. We decided there were 3 basic kinds of links within our network, and I'll get to those momentarily. And so it really comes down to what are you optimizing for? What are the things you need to know when you do a trace route? What are the things that will make your engineers, your operators' lives easier when you actually name things? If you, for example, one of the things that we did is say, reading the trace route is the most important thing. The trace route must have the correct information, and things followed from there. Informative is more important than brief. I'm going to repeat this again. Informative is more important than brief. You want brief? Use a CNAME. This comes back to abbreviations being, the abbreviations being the heart of all poor naming decisions. Everybody abbreviates differently. Keep the names as long as they need to be and no longer. People will type in longer names if they can be derived. This has been shown. I actually wanted to work with the psych department on it, but they wouldn't let me. DNS is not for asset management. Keep vendor type, make, or model out of it. It does not belong there. So here's the specifics. We decided on 2 separate syntaxes, one for multi-home devices, one for single-home devices. For routers, there were 3 types. We decided there were 3 types of links in our network. There were border links, that being things where we do an administrative handoff to some cloud. This can be inside or outside the network that Tufts University Networks controls. So an internal department, which we give them a pipe and shine light down and they do whatever they want, or to one of our transit providers or what have you. Transit links, interim hop, somewhere bouncing around the network. Then terminus links, which can be, as it says there, a last hop, usually a client network or loopback, or a layer 2 handoff inside the network. So as for router names, we give them the role and the priority. So Sackler RTR is the abbreviation that we decide on for router. That is the standard, and that is what we use. Sackler router PRI, Grafton router PRI for the primary router to the Sackler hub, the primary router to the Grafton hub, or border sec for the secondary border router. The reason for pri and sec, not 1 and 2, is because they're actually genuinely primary and secondary. Had they been just 2 routers side by side that were being, instead of border pri and border sec, if they were equals, then they would be border 1 and border 2. For layer 3 links, we decided to name them from the origin point forward. So once again, you read a trace route, it tells a story. The layer 3 interface from the Sackler router connecting to the Grafton router is Sackler router PRI x Grafton router PRI. Reverse the name around the X in the middle, and you get the other interface at the other end of the link. The interface VLAN 80, just a leaf that serves a raft of switches. On the Anderson hub routers, Anderson router PRI T VLAN 80. Likewise, the handoff to the EECS department network is Anderson router PRI -B -EECS, because we don't govern their network, we don't do anything, so we just use a mnemonic. It enters their cloud, it leaves their cloud. Now, one thing that we had to deal with is where things were neither fish nor fowl. For example, the managed WAN link between our Boston and Grafton campuses. Well, we could have named it Grafton X Boston, Boston X Grafton, but we could name it after, we could say there are two border links to our provider, that being Grafton B provider, Sackler B provider. In the end, what we decided to do is, since what we were optimizing for is readability of a trace route, that it would be named Sackler B provider, because that would tell us who to complain to when things happen. Because even though it is presented to us as a point-to-point, we don't actually know how they do this in their internal network. So, given that, we need to be able to tell, okay, we nag provider when a trace route halts. Other switches and other single home devices, it's simpler. Use the building name, RM room number, or RMC if it's the ceiling of that room number, which is what we use in case of APs, and the type in the instance. The first switch in the room 124 to the 4 Colby Street building is 4 Colby-ST-RM124-Unit 0. Subsequent switches in that building would be Unit 1, Unit 2, Unit 3. For the ceiling of room 168 in Page Hall, for an AP, you have Page Hall RMC 168-AP0. This comes in really useful when you have someone in the field call up and say, hi, I'm in Miller Hall, room 050, and about to swap out card 7, and you know, okay, that's Miller-HL-RM050-Unit 0. That's a good first guess. And you know what you're doing, and you don't have to look that up anywhere, you just know. As for implementation, a lot of planning, obviously. Pre-generating the names, coming up, naming everything. Where it breaks down, go back, look at your assumptions, try again. But generating every name beforehand and not figuring them out on the fly and not cheating, being no concessions were made, as long as you don't cheat. So you're saying, well, isn't it easier to abbreviate this or leave this out or factor this out? And the answer is no, you deal with it, because otherwise you're going back to abbreviating an ad hoc naming scheme in the first place. It was daytime changes because it was only stuff in group. Nobody else actually touches those devices besides network engineering. As for backward compatibility, there's a lot of things where, okay, everybody, you can go by the full name, you can go by some abbreviation just because this is the way people have been typing it forever and it's quicker for them and they know what it means. And so you put C names in on top to give them the brevity they want, even though the underlying scheme is consistent. It worked. Good. Yeah. Surprise, it worked. Because if it didn't work, it would be a lot more interesting story, I tell you. So what do you have? A consistent, derivable, and self-documenting naming scheme. It does exactly what it's supposed to do. You deploy a switch, you know a room number, you know what the name's going to be, you put it out in the field. You have a router, you know exactly how to name the interfaces. You have point-to-points, you know exactly how to name them. It makes for quicker deployment, it makes for quicker debugging, it makes for faster security responses when you have to hop from switch to switch that won't necessarily show up in a trace route, well, won't show up in a trace route at layer 2. And people did adjust quickly. People, because it says, typing a longer name is faster than needing to look it up. And once again, this goes back to this random set of characters that someone told you to type versus a concept in your head. If you know the name of the building and you know the naming standard and you know the room number, you know how to type that name, and typing out 20 characters doesn't look so bad. So the lessons learned. You'll always have to make assumptions. Don't look for a universal naming scheme. It doesn't exist. X500 tried, and now you have a naming scheme where it assumes that the known universe has email and doesn't scale down. In the case of point-to-points, yes, we could have named both ends by their T names, but we decided to name them by an X name instead because it made more sense in a trace route. That was something we were optimizing for. Pre-deriving all the current names was the best test we could have possibly done. And that's pretty much it. As for acknowledgements, the Knott Group, Mark Jimenez, Robin Garner, Bob Moran, who's in the Gulf right now, hope he comes back, Joel Gridley, Linda Van Horn, Peter Radcliffe, and Nikolai Plum, Kato Keaton, and Aaron Block for relentless discussions on the topic. So, that's me. How about you? Any questions?
One quick question. Matt Vitak from Yahoo here. Did you run into issues with devices? I'm assuming you put names on the devices themselves, host names, for example, naming interfaces. Did you have to make any compromises or change your paradigm based on devices that simply say, okay, you've got 21 characters or 14 characters for a host name or for an interface name?
Fortunately, we did not.
Simply not having any of those devices?
We didn't have any of that. We didn't really have it. Well, actually, we did not, in fact, have any of those devices. Had we run into that, obviously we would have had to rethink things. But we had the luxury of, that was one of the things we checked for first. Like, okay, according to this naming scheme, because you pre-derive everything, the longest name we're going to have for a link. Well, because remember, a link name isn't going to exist on a host. It just exists in DNS. So the host name, for example, the longest name that exists is between our routing hub in Miller and our routing hub in 200 Boston Ave. So you have 200 Boston-Av-RTR-PRI-X-Miller-RTR-PRI. And that's, kind of big. But you're not actually putting that on a device anywhere. You have instead, you have Miller RTR-PRI and 200 Boston Ave RTR-PRI, and those are your two devices. And so you're not actually putting that thing on a device anywhere.
You never put interface names in based on this?
Never put interface names based on. Oh, I see what you're getting at.
As in the link between the two. Let's put the interface name on.
Oh, I see your point. I see your point. Typically, in that case, we do put them on. It happens that Cisco descriptions can take those, and you get this thing. But in the end, or you say in the description, link to there, or -x- what have you, because the front part is assumed you're standing on top of the box.
I think a lot of the reason you end up with those very horribly truncated names that you had in your first few slides were there are, for example, CatOS or hybrid-based devices where you are stuck with very short naming fields, unfortunately.
Oh,
so
certainly.
Looking at your vendor limitations is probably one of the early steps in the process here that people need to think about.
Certainly, certainly. Any other questions?
Just a quick comment. Thank you very much for putting this together. I thought the presentation was very practical, and I'm kind of curious, what are the next steps? Given that you have a systematically derivable naming convention, do you have any foreseeable applications, I don't know, in the area of auto-discovery or anything like that?
Well, number one, this allows for stuff exactly like auto-discovery, where you can say, okay, well, here's Anderson Router PRI. Figure out what's directly connected to it, generate your entire names. I mean, because in the beginning we had to manually generate everything and put it all in. And it is a tribute to Robin Garner, Network Engineering, that we have a DNS allocation database tool that is easy enough to use and quick enough to use that it went very, very quickly. But what you have is you're allowed to do, you can now do auto-discovery. You now allow for event correlation, because you can have a machine take apart the name. You have all these devices reporting, and you no longer have to, let's say, use Nagios for ping monitoring. Well, you now no longer have to manually generate the parent relationships in Nagios, because you have encoded in the name the parent relationships for a great deal of devices. Or you can do a trace route, take it apart, and cobble names together out of a trace route's output. Yeah. Any other questions?
Thank you, Matt.
Thank you.